go ahead and start off.
Okay.
Introducing David Baum from Phillips Lighting of North America.
Very good, Eric. Thank you so much for that introduction there, and I'm pleased to be here today to talk a little bit about LED street lighting and really a lot of what I consider things to know and just things to consider, because we have a lot of new technology that we're having to digest and understand that we didn't have 3 or 4 years ago. So hopefully this talk here will kind of give you a little bit of information and help you move into the future of LED lighting. The images on the front here kind of cover, I think, say a lot about what's happening in our industry. Where the left-hand side shows Los Angeles from Mount Wilson of what it looked like in 2008 before they changed out roughly about 100,000 of their HID streetlights. And on the right-hand side is what it looks like today. And I think you can see a tremendous reduction in the glare and the trespass, light pollution that LEDs has really brought to the city of Los Angeles. So I think it's a good indicator of what other installations could look like in the future. So the agenda items we're going to cover today, mostly on some of the markets and the market trends, a little bit on technology. We'll talk a lot about on the lumen maintenance, testing, life and reliability of products, and the process and the progress that we have made in that area over the last 3 to 4 years. We'll talk a little bit about outdoor products and controls and wrap it up, covering the IES updates with some of our industry standards and a lot of what we've been doing in the last 3 or 4 years to ensure that each manufacturer is testing their products in a similar fashion. So on the outdoor market side of the equation, I think one of the most important facts here is that if you just look globally, that lighting accounts for about 20% of our global electric use. Within cities, about 75% of all the energy that is consumed today is done by cities and the people that live in those cities. And outdoor lighting for a city accounts for about 20 to 30% of the city's electric bill. So you can kind of see that any energy savings that we can bring to a city or an installation can have a big impact on the expense and the cost of the city's electric bills, but also the demand that is being put on electric utilities to build new power plants to accommodate with the growing need in our society. Just about any and every application and market that is in need of outdoor lighting, I believe today LEDs are ready for those markets and can really bring a lot of value to any and all of these markets served. So some of the applications that we're talking about here today: roadway lighting applications, pedestrian environments, tunnels, site and area type lighting, parking lot lighting, canopy, perimeter type lighting, and parking garages. So just about any and every application, again, in the outdoor environment, I believe in today's environment, LED lighting is ready and able to really provide a big benefit in these different applications. And I think there's a lot of change that is going on in our society as a whole, and cities and government are going through a major transformations, and cities are growing. The demands on cities are growing greatly, whether it be for power, roads and highways, water, you name it. The cities are growing, and we're seeing a lot more urbanization in our cities. And with that, we're seeing a lot more what we call connected outdoor lighting. Lighting by itself, for many years, when we're dealing with HID technology and fluorescent technology, we had what we considered kind of dumb luminaires. All they did was turn on, turn off. They provided light. They provided a good function, but they really weren't connected to anything else. And so what we're seeing now is where the streetlights are connected to other types of lighting systems, other types of control systems, how can we control the lights by the weather, as weather changes, as a storm comes through, as emergency activities take place, or as the needs of a facility change. The lighting has to be able to adapt to those. And with electronics and LED technology, I think we now have a source and equipment that can really be more adaptive to our environment. So again, as we talked about, we're kind of moving from dumb to smart lighting networks. And one of the things here, if I can get my little pointer to work here, is this whole area here of smart dimming, scene setting, remote monitoring, asset management, and intelligent metering and billing. So all of our street lights today, or all of our outdoor lights, can become more intelligent, so that you can really understand what assets you have. You can remotely monitor them. You can dim, you can set different scenes. So you're going to see a lot of change as LEDs become more utilized in the marketplace. You're going to see a lot of change relative to controls and how we control those lights also in the future. And again, as I mentioned, these lighting systems have to be integrated in other services. So whether it be city services, facility services, you'll see how the public lighting is integrated into more and more of our services and our operational exchanges in the environment. So just some additional facts here. Our projection is that by 2015, we'll see LEDs will become about 50% of all the lights and luminaires installed will be LED, and growing to almost 75% by the year 2020. So in a very short period of time, we'll see a big transformation of moving from incandescent, HID, fluorescent technology into the LED environment. But there's a lot of great opportunity here. Why are we doing this with LEDs in general? Obviously, there's a big potential for energy savings through lighting upgrades, and a lot of the business and a lot of the work that we're seeing today is really in these lighting upgrades. And you can do a lot of different ways here, where you can go from, if I can get this little thing here to work, from just doing new lamps, just changing out your old lamps and ballast to new types of lamps. Maybe you change out lamps and ballast, or maybe you do a complete new luminaire system with LEDs. And then finally, the most efficient way is if you incorporate that with control systems. So I think you'll see a lot more upgrades and integration of LED luminaire systems with controls, which in the end run will allow us to give you your greatest potential energy savings. So what are some of the drivers? Why are we doing this? Obviously, I think the payback, the reduced payback is there now. Most installations today, you can get a very favorable return on investment, and prices are such that I think you'll see more and more people adopting LEDs. And I think also the quality of the light is a lot better to what we had 3 or 4 years ago. So the uniformity, the color rendering, the color temperatures, the optics, the performance is all a lot better. And we also are being driven by a lot of sustainability standards, such as the government has and states and local governments have, that are really driving a lot of this as well. So I think everything is getting aligned a lot better today, and to where you can get a good return on the payback, you can get a good quality system, and you can meet all the sustainability goals that you might need. So with that, we'll just kind of go into a little bit of some of the technology. I won't go into a lot of detail. We can spend a lot of time on each one. But we'll talk a little bit about LEDs and in general. And, like a HID system or any type of incandescent system, LED is no different in that we bring electricity into the LED, we get light, and we also generate a lot of heat. And so we're going to talk a lot about heat and heat management, and why heat is so important with LEDs and the design of luminaires to be able to make sure that we provide the long life and longevity that we're looking for with our luminaires. What we're talking about also is there's illumination grade LED sources. There's a lot of different types of LEDs out there available, but you should look for products that are using these high grade, high power devices that are designed predominantly for illumination and illumination grade versus the type that might be used in dashboards or indicator lights or other types of LEDs that are out there. So you really want to make sure that when you look at the products that you're using a high grade, high power device. But if those of us that are familiar with HID fixtures, there's a lot of similarities between LED and other types of HID lamp anatomies, I like to call it. They all have basically a source of where the light is generated. They basically have some sort of envelope. On the right side, the HID fixtures had some sort of glass envelope. The LEDs have a silicone type of lens. They have some other way of interacting to get the power into the lamp. So whether it be through wire bonds, like we had with the LEDs, or the screw-in the sockets like we had with HID, the concept is basically the same. And they have cathodes so that we can get energy to flow through the lamp. So in general, there's a lot of similarity by the way in which the light is generated, just basically in a different type of envelope than what we're used to with HID sources. But most illumination grade sources actually start with a blue LED, and then there is a phosphor coating that goes over the blue LED. And the phosphor can either be directly deposited on top of the blue LED, or sometimes you'll see fixtures that have a remote phosphor system, where you might see a yellow covering over the fixture. But combine in the way in which colors combine, if you had a blue light and it goes through a yellow phosphor, that's how you end up with a white light. So, but you'll see that most fixtures that we are using today, and most LEDs that we're using today, are blue LEDs with this yellow phosphor. Within an LED fixture, one of the more important things that we have to deal with is the thermal management and the heat management of the system. And not only the heat that the LEDs generate, but also the drivers, any control systems, the power management system. And so that's a very important part of what we have to really design when we design a quality fixture that's built to last. And then the other part of the equation is, how do we get that light, and how do we mix it, how do we diffuse it, how do we extract it through an optical system so that we actually get usable light and the light is being used and being put where we want it. So the fixtures is become a lot more complex than what we had with HID or fluorescent fixtures, where we had a lamp and basically a reflector and some sort of ballast. So we've had to really redesign and really rethink how we design luminaires with LEDs. So why thermal management? Why is heat so important? Well, basically excess heat. If we get too much heat on the LED, they can reduce the light output and shorten the useful life of the LED. So extracting the heat through some sort of heat sink is very important. And so the luminaires have to be designed to channel the heat away. And we have to make sure we have the right thermal path. So you'll see when you inspect and look at LEDs and LED luminaires, you really got to inspect and really understand the thermal management of the luminaire, what the manufacturer has done to make sure the heat is being extracted away from the LED so that we don't get a shortened life and reduced light output of the LED. So this is a very important part and something that's new and something that we really have to look at a lot differently than we did with our HID sources. So thermally, there's a lot going on, so we're doing a lot more different thermal management and thermal design of our fixtures than what we ever did before. There's a lot happening with the airflow of these fixtures, how the air has to flow into the fixture and out of the fixture. So it's just something that we've really had to redesign and really think about our luminaires and how do we extract the heat, how do we get the air to flow around the fixture to help cool it off. So those are things that you should also look for in the fixtures that you're considering, is how, how is the manufacturer, again, extracting the heat from the luminaire. So, once we kind of have a good understanding of the fixture design, the thermal management, the LEDs themselves, which ones we're going to use, one of the biggest things that the industry has been working on for the last 3 or 4 years is its testing, and predominantly through the IES or illuminating engineers. When we started with a lot of LED technology back 3 or 4 years ago, there really wasn't a lot of standard testing out there. It kind of was, I call it the Wild Wild West, where we had a lot of different claims. Everybody was testing their products differently. When one would make a claim on life, it didn't necessarily match the same types of parameters that another manufacturer would have. So over the last 3 or 4 years, we've done a lot to really simplify and get our testing in line. And I think today we have a pretty good, robust testing system, a lot of different standards that we have to follow. New ones are coming out all the time, but we still have a lot of work to do. We don't have all the procedures in place. So you'll be seeing, I think, more and more testing procedures coming out from ANSI, IES, and other industry organizations. But what I want to talk about today is a little bit also on system reliability. We spend a lot of time, talking about LEDs and the reliability of the LED systems. But the LED is only one portion of the system that we're talking about here. We have an optical system, we have an electrical system, we have mechanical components, we got the thermal management system, we have electrical connections. So when you look at a fixture, you look at the complete design, it's very important that you really look at the whole system reliability and not just the LEDs. So when we talk a lot about LEDs, a lot of our testing is built around LEDs. There's still a lot going on in the fixture that you really have to be aware of and look at the entire system reliability. And there's a lot of information out there also about the the efficacy or the efficiency in which we can extract light from the LEDs. And we see a lot of information as shown here on the left hand side, where we get information on so many lumens per watt has been developed at the LED level. But again, that's at the LED level. It's not necessarily how much lumens or what the lumens are that are actually going out onto the street or to the surface. So once we start with the LED, we have to go through some sort of optical system. So we have some optical losses, which could be as much as 6 to 15%. Then we've got some thermal losses within the fixture. So again, we have another 5 to 15% in thermal losses. We got some driver losses that are another 10 to 15%. So when we started out with an LED that had, say, 130 lumens per watt, by the time we get that LED put in a fixture and we get how much light we're going to get out onto the surface, we're down to maybe 90 lumens per watt, say in this example here. So it's just something to be aware of. You have to really look at what is the system efficacy, not just the LED efficacy, and how good is the manufacturer doing in getting the light that the LED is generating, getting it out of the luminaire. And then in addition to fixture efficiency or lumens per watt, we're seeing a lot of standards out there today, codes and standards being written where you have a limit on how many watts per square meter you can actually use to illuminate, say, a parking lot or an indoor application. So you'll be seeing a lot of different types of figures and values that are going to be put in place to address this whole issue about application efficiency or how many watts per square meter. So again, that's just something to be aware of that you'll be seeing more and more in the near future. These two charts here kind of show a little bit of impact of how junction temperature or the temperature of the LED at its junction point next to the heatsink, how its junction temperature could impact the luminaire lifetime. So in the chart on the left here, you can kind of see as the junction temperature goes up, at the top, the LED just kind of goes along and doesn't have any impact. But once it gets, in this particular example here, above 130 degrees centigrade, you can see that the lifetime drops off quite dramatically here. So this is one thing that the luminaire manufacturers have to do, is to make sure that the LED never reaches into that type of junction temperature. And the light output also, you can kind of see here, has an impact as well. And the example on the right, again, shows an example as the junction temperature increases, the potential output of the LED also decreases here. So again, this is just something that the fixture manufacturers have to design into their fixture and make sure they manage accordingly. So what are some of the testing procedures that we have in place today? Most of you are probably familiar with the IES LM80 standards. I spent myself 6 years on the IES board of directors, and during my time there is when we kind of developed these standards, LM80, LM79. But this is really a test method really just strictly for the LED package, array, or module. It does not cover any testing relative to the entire luminaire. So that's just something to be aware of, is that when you see an LM80 report, the report is strictly at the chip level, and it comes basically from the chip manufacturers. So with that, you get some sort of report that usually produces a bunch of tables and graphs and a lot of raw numbers. And an LM80 report can be 30 or 40 pages, but there's really only a couple charts and graphs that make a lot of sense and things that you can use. So it's just a set of data points and raw data tables. It's hard to really interpret what it means. But with that, once you have that data, there are things that you can extract out of it, and one of them is lumen depreciation. So you can start doing some extraction of what type of lumen depreciation you're going to get, how stable is the chromaticity, and some other system reliability modeling can come out of the LM80 data. So it is something that's very useful and something that we use quite a bit, but just the raw numbers are kind of hard to use. So this is an example of one of the graphs that you can get out of an LM80 report that kind of shows what the lumen depreciation is over time. And typically an LM80 report is tested at either, in today's world, either 6,000 or 10,000 hours. So you get some sort of known lumen depreciation, say at 10,000 hours, and then you have to be able to predict what's going to happen after 10,000 hours or 6,000 hours. And that's kind of where TM21 comes into play. TM21 is a standard that I'll talk about in a second that helps us really understand lumen depreciation beyond the LM80 data. LM79 is basically a testing methodology for the luminaire itself. So it allows us to, this is kind of where we get a lot of the photometric data, a lot of the performance, color temperature, CRI, and other data that's pertinent, again, specifically now to the luminaire. So with that, we get an IES file out of the output. We get a bug rating. We get the calculated voltage, current, power efficiency, and efficacy. We get the IES type, color temperature, CRI, the spectral distribution. And so it provides a standard procedure that all manufacturers have to follow, so that when they kind of talk about what their efficiency is or efficacy is, they're using the data that was generated from the LM79 test. So again, it's a way of ensuring consistency from one manufacturer to the other. Also, a big part of the testing procedure is some things that we do for UL, where we do specific in situ temperature tests to make sure that the drivers here, or you can see here the LEDs, that the junction temperatures aren't exceeded. So this is again an important set of data points that are very important for us to really calculate and evaluate again what the lumen depreciation is in the life of a luminaire. So these are tests that each of your manufacturers should be able to provide and provide you with independent tested test data. And this might be what you might see with a test report. You can see on the left, the lower left-hand corner, a lot of the different LEDs that are tested. And on the right, it kind of shows what the different temperatures are. And looking at any one individual number may not mean a lot, but collectively, there's a lot of things that the manufacturer needs to look for here and make sure that he's maintained and is within those junction temperatures that the Illuminator report say you should stay under. So again, these are just some things that each manufacturer should be able to provide to you. But what do you do with all this data? Now that we got a lot of different data from LM80, the IES again came up with TM21 as I mentioned before, and now collectively with LM80 and TM21, which gives us a methodology to predict and project what the lumen depreciation is going to be, we have something that I think is more useful for the user and more useful for the end user and the manufacturer to use. So basically it supplements the LM80 data. It was developed as a joint committee by the U.S. Department of Energy, Pacific Northwest National Lab, and several manufacturers. So basically it allows us two functions to extrapolate LM80 data to get what we would consider now, I think you might have heard a lot about, say, L70. And L70 is what is the lumen depreciation, or what is the amount of time that a fixture takes to get to L70 or 30% lumen depreciation. So it allows us to extrapolate that information, and it also allows us to interpolate based on different temperatures. So if we have an environment, say, of a heavy industrial facility or some facility where we might have extreme temperatures, we can interpolate LM80 data to different temperature points. But to help us along the way, the Department of Energy recently came up with this TM21 calculator. And if you go to the Energy Star website, you can download this TM21 calculator. It's a spreadsheet. And now it allows us to take all this test data that we have, and we can come out now with some new projections in life in lumen depreciation, either as reported, projected, or calculated, as they call it. And with that, the spreadsheet has a lot of inputs. So you kind of go through all that test data that I just showed you there with LM80, LM79, your in situ tests. You put all that information into this large spreadsheet that the Department of Energy developed, and then it gives you an output. And with it, it allows you to then to be able to make certain claims as to what the projected life is and projected lumen depreciation is of a luminaire. And so this is an example here of a report that was completed. It was filled in, and you can kind of see here in the bottom left-hand corner here at a certain case temperature of the luminaire. If all these parameters came into play, then you as the manufacturer could claim a calculated L70, in this case of 244,000 hours. If the case temperature was, say, 105 versus 85, then you could claim 102,000 hours. So again, it's a way that each manufacturer is now using the same methodology, the same tools, and the same formulas to create their lumen depreciation and the life claims. So I think you'll find more and more manufacturers making this information available to you, and it's something that you can ask your manufacturers if they have their TM21 Energy Star spreadsheets that they can share with you. And with that also, then manufacturers then can provide some sort of lumen depreciation curve. So again, you can use this in your lighting design calculations to determine what your lamp lumen appreciation values are. So this is an example here of a fixture, and if you wanted the different drive currents and you wanted to look at what is the lumen appreciation at a certain number of hours, you can get it off of this chart here. So again, this is what you would use in your lighting design software, your calculations. So with all that, we have a lot of test data, a lot of information, a lot of new information, a lot of things that we didn't have a very short time ago. And we're all having to kind of learn this along the way. But I think it's something that you're seeing, that we should have a lot more standards in place. You should have a lot more confidence in the claims that manufacturers are making today, as long as they can provide you with this test data. So in summary, the LM80 data, again, is the lumen maintenance at the chip level and at different drive currents. The LM79 provides the lumen output, the IS files. The TM21 provides a method for extrapolating lumen maintenance. The in situ temperature test, just as a way that we ensure that the LEDs are operating inside the recommendations from the manufacturer. The Energy Star TM21 calculator is a new tool that allows us to combine all this into one report, and with that we can get these lumen maintenance curves. So I think you'll find that we're doing a pretty good job of getting all of our data and all of our testing in place, and we're doing a pretty good job of making sure that we provide accurate data so that you have confidence in the products that you select. Okay. So with that, that's kind of on the testing summary here, and if there's any questions along the way, you can again put them up there in your Q&A section there on the left-hand side of your screen. And as we move forward here and kind of get to the last part of our presentation here today, I want to talk a little about on the LED outdoor products and controls, which again I think is very important. And I think one of the things to look at LED luminaires is just the way in which they provide a lot higher uniformity and reduce the glare. And I encourage you to look a lot at the U.S. Department of Energy's Municipal Solid State Lighting Consortium website, and also the Energy Efficiency Renewable Energy websites from the U.S. Department of Energy. They have a lot of great case studies, gateway programs, and a lot of work that they have done to really validate and verify the utilization of LEDs. But you can kind of see on the left-hand side here, with LEDs, we get a lot better uniformity than with HID fixtures, which is what's shown on the right-hand side, where you tend to always have these little hot spots underneath the fixture. So I think one of the important things that the LEDs does provide is high uniformity and also potential to reduce glare. But we also have to be aware that there's some concern that we're getting our streets and highways and parking lots too uniform. And I don't think we'd ever thought we'd say that, but just a lot of the test data has shown, because we see by contrast at night, and so just something we have to be aware of, that we can almost get our installations too uniform. LEDs also can help reduce light pollution, and one of the reasons being is that we can now take the light and better control it, so that we can reduce the amount of light, say, that is being that's in trespass, either behind the fixture as spill light, in front of the fixture, or behind the fixture as light trespass. We can better control how much light is going upwards into the environment. And we really do a lot better job of putting the light onto the surface where it's needed. And so what we're finding today is to get equivalent light levels on the, say in this case here, the street, we can get and use a fixture that has a lot less lumens than, say, what the HID fixture might have produced previously. So this is just an example. Again, this is just an example of one product here that might give you a sense of a rough estimate of some comparables when you do all the photometric layouts. So you can just kind of see here, again, every installation, every manufacturer is going to be different. But you can see here, say, if you had an existing high-pressure sodium 70-watt fixture today, you may be able to replace that with as low as 37 watts. If you had a 250-watt pulse start metal halide area light fixture, you may be able to replace that today with a 105-watt LED system. So again, every installation is specific. Every manufacturer is specific. These are only here for guides and rough estimates. And you have to look at each application and look at each product specifically to make sure that you pick the right product for the right application. And one quick way you can do that here is you can just insert in a simple grid pattern here two fixtures. In this case here we have a 250-watt metal halide fixture on the right and a LED fixture on the left. And this was a 135-watt LED versus a 250-watt metal halide. And you can kind of see here at the table at the top, and I think this was at a 30-foot mounting height. You can just look at the average illuminance, 0.12 for the metal halide fixture, 0.19 for the LED fixture, and you can look at the min-max and some of the uniformity. So this is just a simple way that you can really just look at one fixture to the other and just do a quick comparison to see what type of output you might be able to expect. So on the outdoor control side of the equation, as I mentioned in the very intro, in the beginning, you're going to see a lot of changes, I think, in the outdoor control portion of our business. Excuse me. And there's a lot of different types of outdoor control systems currently available. And one system that you can look at is at the luminaire level. So you can have some smart controls that are just put in at the luminaire level. Maybe a simple occupancy sensor, maybe a simple on-off that kind of makes the luminaire itself smart. You can look at a system. It might be just a single parking lot, a single application, where you just maybe have a small number, 50 to 100 luminaires that are interconnected. Or you can look at a large, city where you might have 15 to 30,000 fixtures interconnected and communicating with each other. And so you can go from the very simple to the very complex. And so the luminaire, again, at the luminaire level, there's some simple control systems that are out there today that kind of allow you to kind of plug and play, kind of forget about it. The fixture just does its own thing. Again, this works well with some occupancy sensors, especially areas that are unused at night, where you want to dim down the lights to, say, 30-40% in the evening, have an occupancy sensor trigger, pedestrian walking by or a car, and the lights go back to 100%. So you can do some basic controls with nothing more than something that's inside the luminaire. Then if you want to get to more of a site solution, you can again have a single site management. Software is loaded on a computer, say at the site. It communicates wirelessly back to the host computer at the site, and it allows you really just to control those fixtures that are in a specific location. So it's very good for single sites, single applications. But more complex types of city solutions, if you wanted to look at multiple bases, say over multiple locations, you could do it. So it's something to really take a look at. Again, the control systems, I think, are becoming more and more robust and a lot more complex, and you'll be learning a lot more, I think, in the future on the control side, whether it be indoor or outdoor. And a complete city solution here basically consists of some basic components where the luminaires are all connected in a mesh network where they're all connecting and communicating with each other. That information gets fed back to some sort of gateway. It collects all the data. It then takes that information through some sort of modem and transmits, typically through a wireless connection to the internet, up to some cloud server, where then you as the operator or owner can get visibility of what's happening, across my entire city or all of my installations. So it's something that's a lot more complex to set up, but a lot more robust and useful in the future. Okay. And so this is an example. We're seeing this a lot with auto dealerships and other types of installations where you can really dim something in off-peak hours and really cut down on the energy savings when you don't need to illuminate it like you would during normal daytime or when the facility is being used. Okay. So lastly, before we wrap it up here with final questions, I just want to cover a little bit about IES standards and Luminaire classifications. The primary standard that we face today or use today is the IES RP8. Now this was originally, the current version that we're using was developed in the year 2000. So it's about 13 years old. I'm also on the IES Roadway Lighting Committee. We've been working on this document for quite a while to really incorporate a lot of the new research that has been taking place with LED lighting and how might it impact the light levels and the way in which we do our lighting design. The current plan is to have this updated this year. We expect that come September we should be able to have a document that can go out for public review and be used moving forward. So we've been saying that we're going to have a new RP8 for a while, but I think time is actually getting closer now. So the IES RP8 currently is based on illuminance. This tells you how many foot candles you need to have on the roadway or surface streets or whatever it might be. The new guide, or the new RP8 that's going to come out this year, the lighting designs are really going to be based on luminance instead of illuminance. So you'll see a change in the way in which we do our lighting design, more based around what we see in the environment versus how much light is actually on the surface. So that'll be one of the major changes that you'll see moving forward. If you're dealing with parking facilities, parking garages, flat lots, the other document, RP20, is the one that covers that. It too is being updated this year to take into account a lot of what we're doing now, especially with white light, and how we might be able to reduce the lighting levels based on the mesopic or scotopic light levels. So you'll be seeing some new documents also on RP20. That'll be coming out as well. Also being inserted into a lot of our documents today is the lighting zones, and you probably have seen a lot of the different definitions of lighting zones that were published by the IES or the International Dark Sky Association. And so within our standards today, we are going to be creating light levels based on the zone in which the application resides. So in lighting zone 0 is kind of like a national park type setting where you may not have any lights at all allowed, all the way up to an LZ4 where you have really high light levels. This might be in a downtown city core area or something like that. And so you'll see standards that are going to be written around each one of these zones. So it's something that you have to be aware of when you're doing a lighting design. And then the Department of Energy and the CBEA, or the Commercial Building Energy Alliance, has also come out with a new standard in LED site lighting design that kind of supplements what's in RP20. So these are to be used in U.S. Department of Energy CBEA type of projects. And it's starting now. Again, it's incorporating the different lighting zones. So you can see here where we have different, say, in the main parking area, and this could be a a commercial building, a big box, some sort of parking lot area, where you have different lighting zones and different light levels depending on the zones. And then you start also defining the area, like in this case here you have the main parking area, or the front aisle area, or the perimeter, or the loading zones, or the entry areas, where you start seeing different light levels depending on the application and the use of the space. So our lighting calculations are going to get a lot more complex, I think, as we move forward here. One of the other things to be aware of is the bug rating, and I mentioned in our LM79 testing, one of the things we get out of it is the bug rating, and it allows us to really be able to identify and calculate exactly where the light is going. So we get a lot of information on the high angle zones, which are important for glare and light trespass. And so it just is a better way of us to really identify, again, where the light is going. And it's something that you should be aware of when you're selecting your products, and something that you should be looking at to compare one fixture's bug rating over the other. And the bug ratings will help you really understand some of the photometric and optical performance of the product. And this is one of the graphs that you would get from a manufacturer that talks about its bug rating. And then finally, the different types of luminaire classifications. Specifically from the IES, we have a lot of different types, type 1, 2, 3, 4, 5. And then we have, which tells us a little bit about the types 1, 2, 3, 4, 5, is how far, say, across or away from the luminaire does the light transmit. And then short, medium, long is a little bit more on the how far right or left from the luminaire does the light, again, transmit. So when you see, say, a type 2 medium, say, compared to a type 2 long, these numbers now become to mean something. So when you compare one manufacturer's IES file over the other, and you see the classification of a type 2 short or a type 2 medium, you can get a better sense maybe of what type of coverage and uniformity you're going to get. So it's just something to be aware of. And so this also kind of shows you the most typical ones and the shape of most of the fixtures. And for most of us here in North America, for our streets and highways, we typically use a lot of type 2 and type 3 is the most common. Europe uses a lot of type 1 because they have a lot more narrow highways. And then when we get to type of area type applications, parking lots, is where we might now bring in a lot more use of type 4, type 5 types of distributions. Okay. And this kind of shows you again some of the types of distributions that you might also see for area lighting, where you might see narrow forward throw, medium asymmetric forward throw, and you see some sort of specialized type of optics and performance for area type lighting luminaires. So that's I think we're pretty good on time here at 3:52. And I'll open it up for questions or anything that anybody else might have. And I appreciate, the opportunity to be here today, and hopefully you found it helpful.
Okay, we have two.
So Eric, I'll turn it back over to you.
We have two questions that have been entered. The first one, a guest asks, do the same results from the TM21 apply to flashlights? I assume he means LED flashlights.
I'm not. They're probably, the data is just sets of data points, so it may apply to flashlights. I haven't looked at it relative to flashlights or what type of data points you get when you test flashlights. But if you have the LM80 data, you have the LM79 data, and you have the IS-TMT data for the flashlights, and my assumption would be that it might work, but I just never have used it in that type of product.
When they test the TM21, is that a test on the LED element or the whole fixture?
Well, the TM21 isn't really a test per se. It is a methodology and some mathematical formulas that you could use to extrapolate the data that's from the LM80. So the LM80 data is at the chip level. So it is the chips are tested as the chips are manufactured. They are tested in a laboratory environment, excluding putting it onto into an LED luminaire. The LM79 data then is now a complete luminaire that has an LED array inserted into it. It has electronic drivers and optical assemblies, and you test it as a complete luminaire. The ISTMT data typically is a complete luminaire, where now you are testing and measuring the individual temperature points of, say, the LED or the driver or such. And then the TM21 is just a methodology and a spreadsheet and a set of formulas that allows us to extrapolate and interpret all those.
Yeah, next question we have is how much more do LED systems cost versus conventional systems?
That's a hard question to answer, and from one application to the other, I think the bottom line is that you are seeing today, and I think in the beginning section there I talked about the return on investment. And if you look at everything in the equation with energy savings, reduced maintenance cost, and all the factors that you go into determining what your total cost of ownership is, in today's environment, I think you'll find that LEDs, for the most part, will outperform or equal what you're using today in conventional technology. So from a retrofit perspective, most applications today, you can make a good argument with your return on investment calculations that LEDs make sense today. And I think that's where we're at today in our environment. 3 to 4 years ago, there were only certain applications where you could really say that it made sense economically. But I talked about in the beginning the different types of outdoor applications, from tunnels to area lights and canopy lights, and almost every one of those applications today, LED makes sense for meeting economics.
Paul writes, how sensitive are the devices to the quality of input power and potential power surges? Are the fixtures or devices designed for EMP protection?
Yes. From the surge protection, there are some ANSI standards. C136 has some standards that we all follow, and the typical surge protection device that you'll find in most fixtures will support a 10 kV or a 10 kA surge, and if you look at the new U.S. Department of Energy's Municipal Solid State Lighting Consortium model specification, one of the appendices goes into a lot into the surge protection that these fixtures will follow and the different types of testing. And then in regards to the magnetic pulse question, there is test data from the chip data and the drivers relative to that, and that would be something you could ask your suppliers to provide all of their test data, and not only the impact on that type of pulse on the fixture, but then also what type of transmission FCC requirements for interference with other types of electrical systems and communication systems you might have, and the manufacturers can provide you with that data.
We got a couple time for a couple more here. One is, how much does adding a system level control to a site parking add to the cost?
Again, each location is different, but in the context of the luminaire, say, again, it depends on the number of fixtures, and so I hate to always put an individual number in there. But again, like any system and any product you buy, the return on investment has to be there, and you have to see a value to that system there today. So, it's hard to put an individual dollar into it. We can always look at individual projects and look at what it might cost, because the number is going to go up quite a bit from the, whether it's 10 fixtures, 100 fixtures, the application, what you want it to do. So, you'd have to look at each individual one, and again, like anything else, you'd have to do the analysis to determine if the added value and the benefit is there.
Another question is at the beginning, the picture of LA from 2008 and 2012 of the light around the city, the LED version looked a lot darker. Why is that?
Well, I think one of the main reasons what you're seeing there, and we can kind of, I don't know if we can get back to the home slide here. You're looking at this image. I don't know if you can get back. There you go, Eric. If you can get back to that photograph there. There you go. Yeah, there you go. So what you're seeing here in the top of the photograph is a lot has to do with reduced light pollution. So in the right-hand side, you're at Mount Wilson, so you're looking down above the city. And what you're seeing is, I think, a lot has to do with the improvement in the optics. You're seeing a lot less light pollution, a lot less light trespass. You're still seeing a lot of reflected light. Obviously, the light that goes down to the roadway and reflects up into the atmosphere, you're still seeing that. But you're seeing a lot of reduction, especially in that center area there, with the high-angle light, because a lot of the fixtures that LA had in the beginning were drop lens HID fixtures, where you were seeing, almost a bare fixture, and the lamp was visible. And now we've pretty much eliminated a lot of that. So that's one of the main reasons why you would say it looks darker. But when you go drive the streets, I can tell you feel a lot safer, and it feels a lot brighter.
We'll have one more question. Last question. The last question is, do you foresee the cost of stabilizing or continuing to go down?
Like any electronics, I think it will still continue to go down, but not at the same rate that it has over the last 2 to 3 years. So we saw quite a bit of drop over the last couple of years. Costs are stabilizing, prices are stabilizing. And it's kind of like any other electronics, TVs or other types of devices. We saw the big drop from what they were when they first came out to where they are today, and prices are stabilizing. So just a normal supply and demand will continue to drive prices down quite a bit or somewhat in the near future, but not at the rate that we saw over the last couple of years.
All right. This will, David, if you could hang on just a minute before getting off. Everyone, thank you for your attendance, and thank you for David for coming out here virtually and delivering this very informative, very in-depth presentation. I look forward to people attending the next sessions that are posted on the website.